So characterisation of unknowns, this is quite a bespoke analysis that we created many years ago from our railway days. It's designed for looking at unknown materials by its name, and these can be anything really. So it can be a dust sample which is in an office. It can be a fuel jet which is blocked up with a sticky residue. You could be on site digging a borehole and some green slimes come out the ground and you want to know what it is. Or you could be doing a clean-up campaign and you've found loads of barrels of solid or liquid where the labels have fallen off and you have no idea what this material is. This is where our characterisation of unknowns come into it. So we will take the sample, we will do numerous analysis on it, and if we can tell you exactly what the material is, then we will do. If we can't tell you exactly what it is, then we will tell you as much about it as we possibly can. So there's many techniques that we will use that we have at our disposals. First one we will always take is a look at the sample. So we'll take a nice image of it and we can describe what the actual sample looks like, which can tell us a huge amount about a sample. We will then move over to the infrared. So we have a microscope attached to our infrared, so we can work for very small particles. So we've worked at small particles which are taken out of vaccines. So if you've got a vial of liquid vaccine, any particle there will fail their quality control. So we will have that particle, so we can work with minute particles as well as, you know, bulk contamination dusts. So the infrared will give us a nice fingerprint and that will be able to tell us what kind of organic materials, polymers, things like that could be present. If there's an odour associated with it, so if there's a solvent odour, then we might do some headspace GCMS analysis looking for the solvents. We will do a solvent extract and then we will do a GCMS scan looking at our semi-volatiles. So we're looking at pharmaceuticals, oils, phthalates, additives, things like that. We'll probably then try to see if the sample's soluble in water. If it's soluble in water or just do a water extract, we'll probably take a pH. So we'll be looking to see if there's any acids or alkalis present. If there are acids or alkalis, it might go down our ion chromatography system looking for the anions and cations associated with acids and alkalis and things like that. We'll probably put it on our scan electron microscope, which has an energy dispersive X-ray analyzer attached. That will give us an elemental composition between carbon and uranium. After all this analysis is done, then we formulate what this material could be.